Good evening, good afternoon, good morning, everyone for joining us online from the different part of the world. On behalf of our platform, I warmly welcome all our participants to the special session. We are honored today to host Mr. Johnny Poulsen, the CEO of Dolenco Tunnel Systems, a distinguished leader with over 25 years of experience in waterproofing and concrete repair solutions. Over the course of his career, Mr. Poulsen has founded and managed business in both distribution and subcontracting, covering a wide range of specialized solutions. He has built deep expertise in tunnels and underground structures across the international market, while consistently driving innovation and adaptation in response to evolving challenges of our industry. As underground construction continues to face changing conditions and increasing demands, Mr. Paulson has been the forefront of developing new strategies and solutions that ensure resilience and progress in this dynamic sector. So today we are privileged to learn from his vast knowledge and experience. So without further delay, it is my pleasure to invite Mr. Johnny Paulson to deliver his presentation. Mr. Paulson, the screen is yours right now.
Thank you for your
No, you
introduction,
can. Yeah.
and thank you for the invitation. And
Yeah.
when you say this
Mr.
about
Paulson.
our experience, everybody is very welcome to, after the presentation, to place their questions about this field where we're talking. The first thing I'm going to do is the presentation is on a number of slides. So I'm going to share my screen first, and then I will start the presentation. Before I do that, just very, very short about our company and our experience. And we have developed these drainage systems that we have now on the basis of the current situation in the market for waterproofing and protection of underground structures. And give me just a second. I can switch to the screen. Okay, so welcome to this session on managing groundwater and hydraulic pressure in tunnels and other underground structures. When you start in a tunnel project, we have to think about this actually quite dramatic work we are doing by removing part of the mountain. What is happening is we are changing the entire dynamics of the mountain. We excavate a whole cavity, and what we do, of course, to try and use this cavity safe and over a long time, we build some kind of lining inside this cavity. The dynamics of removing all this material, of course, will change because it has had millions of years to have a certain balance and the dynamics in the soil around the cavity. It's very dramatic. So the whole mountain will try and find a new dynamic in this new situation. So what does it do? It starts by putting pressure into the cavity, the tunnel, and it also starts changing the way water flows because of this. These factors are very important in the beginning of the project and even over the long-term use of the tunnel. So when we start excavating, we have to take this into account for what we're doing. And these changes that occur are very variable. So we have to be very, very careful as we make the tunnel. Next thing is when we actually start making the lining, the construction of the tunnel lining itself. This lining is also subject to this soil pressure dynamics change and the water change during construction. So actually it starts settling and the rocks start moving a little bit. This is also what we have to think about. And then, of course, from making the appropriate lining inside the tunnel, We try to foresee all the coming problems that could occur over the lifetime of the tunnel. That means the next 120 years. So this is actually a very big task that we're giving ourselves in designing these tunnel linings. They are, of course, not without problems, these linings, when we build them. And as you see here to the right, you see some of the water problems that we have. We don't know if it's going to be like this before we start digging, but sometimes we see areas where you have actual water flowing in, trying to make a new balance inside the structure. So when we have these problems with water coming in, the water pressure and the accumulation of water inside, we have to think about that even when we start excavating. So during construction, we have to maybe make new, some pre-grouting, or we have to make some line drains or some other parts of the components of the lining that will make it possible actually to build this lining. If there's too much water coming in, for example, the shotcrete will not stick to the surface, and you cannot really get any further in that case. So we have to have a lot of different tools to manage this. This makes it very complicated again to do this lining and to make a safe long-term project and tunnel. And of course, the last part is that when you have built the structure, it will have to hold all that water pressure, and hold the structural pressure for the lifetime of the structure. If we don't do that, we have a high risk of the need for repairs over the lifetime of the structure. This is one of the very big costs that we see when we make tunneling. The unforeseen repair work that we do over time. So with that in mind, we can look at some of the specifics of what is it that makes it a problem. First of all, we have the safety issue when we are constructing. Water coming in, the risk of rocks falling off. We need to make initial lining that actually can hold the structure while we're working. When we're doing the lining that we have designed for the individual project, we will often have the need for repairing of this lining during construction, simply because the water's coming in, damaging the lining. Again, if you are in certain areas, let's say you're up in the mountains and it's very cold, ice will form. That is also a source of many different types of damage, even fatal if the ice falls onto a car, onto a train, or the ice on the roads and so on. So these are the things that we really want to avoid and try to avoid by making the proper lining design. If we have these different problems, it is very costly to repair them, and it takes a lot of time. And closing down the tunnel is also a big cost for society, and adds to the cost of the problems. So specifically, what are we doing when we have all this water? We're trying to block, first of all, to block the water from coming in by grouting, making waterproofing, so the water doesn't have a chance to get in anywhere. Second, we are using the diversion, where we use the different types of drains, pipes. It can be sheets, simply to let the water run somewhere, and this way avoid that it comes through the structure. The last option is often, since it is not possible to stop the water, you simply just let it drip, and then you take the long-term problems with repairing, doing injection work, repairing the concrete, and repairing a number of the installations which would be in the individual tunnel. So when we are going to design this lining, what are we looking at? First of all, we have the concrete, the shotcrete. And for that, we can do a number of things. We can make it fast setting. We can use additives for less cracking. We can even use some very heavy lining, just using extra concrete to take the pressure and the water coming through. We can stabilize the arch with steel girders. We can place anchors, and we can use wire mesh for the stabilization. This is, of course, it depends on what you're talking about. If you're having the hard rock tunnels, or you're using or you're having a soft rock tunnel situation. And depending on this, you of course use different solutions. And this can even be in one project where sections are made in one way and other sections are made in another way. For drainage to alleviate the water pressure, the hydrostatic pressure, you can use punctual line drains, you can use dimple sheets or geotextiles. Many of the problems comes from having the linings separated. So the outer lining and the inner lining are separated, meaning the inner lining will have to be much more strong because it has to be self-bearing. So this is some of the problems that we have with using enough space in the tunnel. Finally, we are using the waterproofing as part of the lining, where we start with the grouting, spray membrane, sheet membranes, fibers mixed into the shotcrete. You can also mix in crystalline waterproofing, which closes the cracks over time, over the first month or so, when there is fine cracks or bigger cracks in the concrete. And then finally, we can use injection. Of course, the injection we can use before any water comes through, but you can also use it for repair during construction when the water is coming out. What we are suggesting to do and have seen really good results in is to make a systematic drainage system inside the lining. With our more than 25 years of experience with waterproofing of underground structures, we have seen all the problems that occur in these situations. By putting a stable, full surface drainage into the lining at an early stage, meaning as close to the rock surface as possible, we can receive all the water that's coming in, and instead of letting it go through the lining and come into the tunnel, we lead it to the base, along the wall, just to the base. So this way we avoid blocking the water, because sometimes this would create high pressure, which we don't want. It's very dangerous to have too high pressure there in these projects when we have a thinner lining. We don't accept any seeping, and we also can reduce the long-term repair. So, and basically what we're doing, the overall headline is to permanently prevent water pressure on the lining. Now, before going any further, I would like to show you a little video which will show the principle of the build-up of the lining. And it is, like you can see here on the picture, you have the rock bed, you have the initial shotcrete lining, you have Dolenco drain mesh nailed onto the surface, and then cover with 1 or 2 layers of shotcrete. Can be done in different ways. But let me start the video. here we see we start at the top and overlap the modules, also horizontally overlapping, connecting. And then we cover with shotcrete. And finally, there's some kind of detail at the bottom for alleviating the water, to leave the water away from there. So as you saw on the video there, the Dolenco drain is made in modules. So it's very easy to mount to the wall. It is the size of a Euro pallet and only 14 millimeters high. So it takes up very little space. 14 millimeter high with half pipes, a network of half pipes. As you can see on the photo, to the left, you can see the strings which are embedded into the concrete. So we only need very little space to mount. Here a more schematic overview of the modules connections. And up to the left, you can see the vertical connections overlapping. So the water goes from one module to the next until it reaches the base. And below to the left, you see the horizontal connection. So the water can actually move horizontally, both between the strings on one module, but also between the modules. So the water can disperse sideways as well. This is an important feature to alleviate the water pressure if you have a local place with more water. So a few facts about Dolenco drain. First of all, the volume of the water that can be let inside Dolenco drain is 8 cubic meter water per linear meter wall per hour. So this is a very high volume and much more than is really needed. If you have a flow of water, this volume, you cannot get the shotcrete to stick to the surface. So it's a very safe margin we have there. And as you can see on the photo to the right, there is only a very thin layer of shotcrete over the Dolenco drain modules. Here in this particular photo here, it's 2 times 50 millimeters and with fibers mixed into the concrete and nothing else. And that takes the water. The water was actually, the most water was what you saw in the beginning. Lots of flow of water. We managed to do it like this with some extra pipes, which I will illustrate a little bit later. The solution is permanent since it is embedded into the concrete. It doesn't go away. The Dolenco drain modules are made of either 100% recycled material or biodegradable material. Besides using it in tunnels, we can also use it in second pile walls, slopes, and other applications. Of course, some of the important points here is also that when you have permanently prevented water pressure on the lining, you have added benefits from, for example, protecting the spray membrane. If you use a combination with the spray membrane, you can also, if you have cracks, you can also have eliminate or minimize the injection needed because the water is not pressured through the lining. It's a very, very easy and quick installation. So it's easy to do the work. And let me show you a small video on this as well. Here you see 4 people. And in this case, they use a scaffold. You can also use a scissor lift. 2 people can mount between 12 and 20 modules or square meters per hour. Okay. So when we look at the modules mounted like this, and when you apply the next layer of shotcrete, you actually have adhesion between the two concretes, the primary layer and the secondary layer. And that means they are both permanent. We have 70% of the surface between the strings, that is for adhesion. And this also makes it possible for you to sometimes calculate less concrete consumption. So the secondary layer doesn't have to be as thick as first planned because it is now adhering to the primary concrete. So it doesn't have to be self-bearing anymore. So we have a monolithic structure now. Some of the advantages that we've been looking at was the construction cost, the direct cost, the CO2, and the work time. And we have seen significant reduction in all three parameters. First of all, the construction cost, the reduced concrete, the easy mounting does make it a lot less costly. And of course, as a result of this, you also have less CO2. The construction time is a very significant factor. And here we see also a reduction, both in hard rock tunnels and in soft rock tunnels. And as you can see on the photo to the right, you can see this is actually a scaffold over the rail that made it possible. This is from Spain, where it was possible now to have the train running while we were mounting Dolenco drain on the wall. So we only need very little space to mount Dolenco drain. So where to use? We talked a little bit about rock surfaces. You can also do it on second piles, on horizontal surfaces, that can be floors or inverts in tunnels, on slopes. Dolenco drain can be mounted directly onto rock, on brick surfaces, and on very uneven surfaces. I'll go through these one by one now. First, I would like to show you a small video here of the second pile application. So here we see how we level out between the piles, repair the reinforcement, mount Dolenco drain, as you see, it's systematically mounted on the surface and with a nail gun. In this case, after applying the shotcrete over the modules, it is also connected to the floor. So the water running from the wall runs into the floor and out to a pump sump, or it can be a drain pipe or other details depending on the project. Okay. So here we see the schematic of the second pile wall application. As you can see, we have a very thin layer of shotcrete first on the second piles, mount Dolenco drain, put a gutter in at the base to collect the water, mount an appropriate number of pipes to lead the water out into different types of canals or pipes to get the water out of the tunnel, depending on the project again. This is why it's not mentioned here more detailed. It could be a pipe in the middle of the floor in a tunnel, or it can be a canal along the side, or There can be some inspection shafts on the side also, and the inspection shafts, you can also use them to flush the gutter if you need to flush the gutter. And the same principle we see here on the rock wall. In addition to this, we also have the Dolenco line drain, which is a vertical drain that if you have a lot of water coming in one point, you just mount the Dolenco line drain over the point and lead the water down to the Dolenco gutter drain at the base, the same way as the water is led from the drain mesh. Here we see the connection between the tunnel arch and that could be a shaft chamber, or it could be a station wall, where you have a specific drain that catches the water coming down the wall and lead it to the sides and down to the base, into the gutter and out. Here we have a very simplified version of how to use Dolenco drain in the wall and the floor. So basically we see the drain on the wall, and over the joint between the wall drain and the floor drain, we put a geotextile, so the shotcrete will not block the end of the modules, making it possible for the water to go from the wall into the floor. And then, of course, the water can go from here into a pump sump or other details, what is relevant for the individual project. Also in slopes, when you have slopes, you can, this could be either it could be hard rock or soft soil. So you would use anchors or soil nails into the surface after a thin layer of shotcrete. And the way you use Dolenco drain here is that you will mount that after the first layer of concrete has been applied with a wire mesh. Put the anchors in, put Dolenco drain on, and then cover with another significantly thicker layer of shotcrete with wire mesh also. In this way, you avoid to have a slope with a lot of holes, pipes coming out of the entire surface to alleviate the water out through the surface. Here, you just catch the water and lead it to the base. And in this way, you avoid all the damages that you see on the surfaces from the water coming out. And since the pipes, they also clog up easily, often you have a pressure that cracks the concrete and the water will come out. When you have Dolenco drain inside this structure, the water will go only to the drain and down to the base. So you'll have much longer lifespan of the structure. Now you can also mount Dolenco drain directly onto the rock. This is done if you cannot get the shotcrete to stick to the surface and you don't have other ways of stopping the water. You can basically just put the Dolenco drain onto the wall, mount a wire mesh over it with anchors and shotcrete the whole thing. That will make it possible to get the shotcrete to stick to the surface. It's a very pragmatic solution that actually is functional. Using Dolenco drain onto a brick surface is done by combining it with a wire mesh and simply just nail it to the brick surface directly without any shotcrete first, and just cover with a layer of shotcrete. Maybe you want to repair the joints first if the joints are very bad, the mortar is very bad there. You can do this. You can also combine the inner lining with a spray membrane and another layer of shotcrete. Typically, we don't need more than 50 to 100 millimeter shotcrete or after Dolenco drain. As you can see here, we have a very uneven surface. The modules have been made very flexible. This means that they can adapt to an uneven surface. And let me show you a small video on that. Oh, yeah. Here. to illustrate the mounting here. So Dolenco drain has been designed specifically to be able to adapt to the uneven surface. The surface has to be wavy, so no sharp edges, and then you're actually good to go. If you have anchors, you can also distort, twist the drains a little bit so it will fit around them. As you can see here, it's just a nail gun and a scissor lift. Very easy nail gun with only a battery, and no big equipment is needed. So you can actually go in with a scissor lift, with a nail gun and 2 persons, a pallet of product. Dolenco drain is delivered on Euro pallets, so it's easy to take in, go in, start work. And this is, of course, important if you have, for example, the repairing of a rail tunnel, where you only have very short window of time to do the actual work. So as I was mentioning before, the complementary solutions there is, like you see in point 3 here, if you have a point where there's a lot of water coming out, you can alleviate that with a line drain mounted over there. If you have, as seen in point 2, you have water coming out that can fit into a 10 millimeter rubber hose. We drill a hole into the structure, alleviate it into the the string of Dolenco drain, as you see to the left. You see the water is coming out and there, and then it's let in there. That makes it possible to shotcrete and to get the shotcrete to stick to the surface. And then, of course, the other parts here, we already talked about that. So to make sure that all the work has been done properly, we have a number of visual inspections that you can do. So basically, you have to be able to see the water coming out at the base after the installation. And I'm not going to go through all the details here. You will have the slides after after our presentation, so you can go through them more in detail. But it's very important that we have a connecting mesh of modules, so you can see the water coming out at the bottom, and that can be done by either before putting in any gutter, any drainage, horizontal drainage at the base. It can be done by inspecting in the shafts where the water comes out, or you can also make sure that all strings are attached properly, not more than 5 millimeters from the surface. And so these are the things that we have to look at during construction to make sure that everything will go well at the end. About how to alleviate the water at the base. Besides the Dolenco gutter drain, which you saw on the previous slides, it's also possible to install a perforated pipe, which you will see here in the middle at the base. A perforated pipe installed and at the base, so the water that comes out of Dolenco drain ends will run into the perforated pipe. And to make sure the shotcrete is not clogging the end of the modules, we mount a strip of geotextile over the end of the modules and around the pipe. And here another detail in the middle at the bottom there is the same as the previous one, but here it is shown in combination with a membrane. That could be a spray membrane or a sheet membrane. Again, this depends on the project, the individual project, of course. Here's another version where you simply let the water run down and out on top of the slab and then go to a drainage nearby. And you just make sure that you don't block the ends of the modules, again with a strip of geotextile. and then don't shotcrete all the way to the base. Here in detail E, down in the middle, the detail E, you see another version, another option on how to do it. And this is where you just take Dolenco drain and mount it all the way past the slab and into a stone drain layer under the slab. This way we just lead the water all the way down to the stone drain layer and have the water run in there. It's a very, very simple and easy way to manage the water there. And then finally, before showing you a couple of projects, here's the schematics of the Dolenco gutter drain. As you can see, it's a gutter which is very slim. It's only 65 millimeters wide. And we have designed it like this so it can be used in very slim structures, for example, in repair work. And then you mount a horizontal pipe to get the water out, as we've seen in some of the previous slides as well. The only thing you do here is that you nail the one side onto the surface at the top, and that's it. So it's a very easy mounting system. So finally, a few projects. Here we have first a road tunnel, and this road tunnel actually collapsed, and after rebuilding the lining, they put on shotcrete without fibers and mounted Dolenco drain and then cover with shotcrete, and that was it. That was all that was done there. Let's have a short look. This project is from Canada, and in reality it was two tunnels where the wall was removed in the middle, and to support the arch a number of steel girders was installed, and the first design was with a spray membrane shotcrete, during construction, there were problems with the water coming in to the spray membrane, and for that reason, the designer changed during the construction, changed the design to include Dolenco drain behind the spray membrane. So the water would be caught by Dolenco drain, and the spray membrane would have time to dry out, and so it can function properly. Here we have an example of a shaft, and the interesting part here is also that the lower part, if you look at the illustration in the middle, the lower part was hard rock and the upper part was soft rock. And for this reason, it's the lower part is anchored with shotcrete and the upper part is second piles. And then the whole thing had shotcrete on it and Dolenco drain, and then shotcrete plus a combination with a spray membrane. In this project at the base, the water was let past the slab into a stone layer, as mentioned as one of the options before. Here we have another example. This is a road tunnel from Russia, and the concrete was so bad that there was a lot of water running through the ceiling, and the reason was also that above this there is a river, and the road tunnel was closed because of this. They basically cleaned out the bad concrete, cleaned the reinforcement, used corrosion inhibitor, new layers of shotcrete, Dolenco drain, shotcrete, and fibers, and also spray membrane, and it was absolutely dry after this. Here we have an example of a brick tunnel. This is in Slovenia, and they had a lot of seeping coming through the joints, bad joints. So they repaired a lot of joints here before putting on Dolenco drain and a wire mesh of fiber, not steel, but fiber, wire mesh. And then after that, they used a render. They drew on, not spray, but they were drawing on the render on to cover the Dolenco drain and the wire mesh. And then they included also a spray membrane. Here, a retaining wall, where the only option there was to remove 10 centimeters of concrete, mount Dolenco drain, and then cover again with 10 centimeters of concrete. This is another type of application in a road tunnel. Here, rail tunnel in India, where it's in Mumbai Metro, where they had changed the design from a double lining with a sheet membrane to a cast concrete to spray to shotcrete. And because of the use shotcrete, they used this because it was faster. They needed some, they had some time pressure there, and for that reason, they also included a number of different drainage methods, including Dolenco drain and some line drain, which you can see, which is not our product, which is there on the left, and Dolenco drain. And I think that was actually the first time using spray membrane in these Indian metros. Yeah, I think that was the first time. Here, finally, the last reference here is a underground railway station with second piles, where you can see they have leveled out a little bit, so it has a wavy surface, and then putting on Dolenco drain, shotcrete again, and spray membrane. And also the ramps were made like this before going above ground. So this is cotton cover station and ramp. Thank you. Let me go back here. Right.
Thank you very much, Mr. Poulsen, for the insightful presentation. Now we will open the session for questions for the from the participants. Dear participants, you may type your questions in the chat box, or if you would like to ask directly, please raise your hand feature on your screens. Okay. Now we have a question from dear Mustaq. He's asking, usually water seepage happens through pores, oblique joints, in tunnels, and hence there are actually fewer points of contact in the wall from where water actually drips or flows. Wouldn't drainage hole drilling be a better option if we talk about construction time and feasibility? A jumbo, especially the one shown by you in the starting video, would need better housekeeping and level surface for the wheels to move, hence adding more to construction time. Moreover, the drain mesh installation is smaller dia tunnels. In smaller dia tunnels itself would hinder access to the tunnel face or other works. Okay. Also, if it is a class, we say poor class, we would already have very less stand-up time. Wouldn't it be impractical to utilize time on drain mesh installation? Uneven sharp surfaces would be another hurdle that needs to be overcome. Mr. Paulson?
That was a very long question. I think the longest
Yeah,
question I have heard.
let me
So,
let me rephrase the question. Firstly, the first part of the question. Usually, water seepage happens through pores, oblique joints in tunnels, and hence there are actually fewer points of contact in the wall from where water actually drips or flows. Wouldn't drainage hole drilling be a better option if we talk about the construction time and feasibility?
well, yes, of course. I mean, it depends on the project. If it is, if this is the way to go forward in the project to use Dolenco drain, because it is meant as a systematic drainage system. So if you have points, you have joints, and so on, then you can use the line drains, or you can use the pipes, or you can maybe even use a sealing with a injection material or with grouting. This is also an option, or fast setting mortars is also an option. If you have a hole, just to have a fast setting mortar and go, this is also possible. When you are looking at the at Dolenco drain as a system, then you have to think about the lifetime of the structure, not just a local repair, but a lifetime of the structure, that you have a system installed into the structure that whenever water comes out anywhere in the walls over time, then you have a system that will automatically take that. I was talking about the dynamics in the beginning of the session here, and that's really the answer, because over time, as I said, during the excavation, during construction, and during the lifetime of the structure, you have a changed dynamic in the structure. And this increases the problems and the risks over time that something new will happen somewhere. And the problem is we don't know where exactly that's going to be. So I would say that you're right, that if you're doing repair work, you can easily do it locally, and that's cheap to do that. But that's what it is. It's a different thing. Yeah. So this is, I would say you could do either method depending on the project really, and the needs and the wishes. You can make a strategy that says we will do repairs every year, every time something happens, or we'll do it one time where everything is done when we build it or when we repair the whole tunnel, and that's it. So that different approaches, right?
Okay, here's also one more question. If it's a poor class, we would already have very less stand-up time. Wouldn't it be practical to utilize time on drain mesh installation? Uneven sharps surfaces would be another.
What do you mean? Very little time.
It means when if there is a if there is a very poor rock mass, then there
Mhm.
will be a very less time standing time of the that very rock. So we have to install the primary support earlier. It
Right.
just yeah
Yes. Well, in that case, well, it depends on if you're talking about I guess if it's a slope or if it is a, if it's a tunnel. But what we do is, what you always do is you always put in the safety layer first, right? You
yeah
put on the shotcrete first. So you start with minimum 30 for us, for our part of the project, for the drainage mounting, we need minimum 30 millimeters of shotcrete because the nails are 30 millimeter. So you need to do this safety first, right? And this can be with anchors also if that is needed. That again, that depends on the project, but you need to have the safety layer installed first, and then you can work with the Dolenco drain. It's not a problem in that way to with the time. Um, so that's what I
yeah
see.
absolutely. There is another question from Mr. Akash. When we talk about drainage, another aspect of that is the settlement of the strata from where the water is coming out. So considering the effect of better drainage system and settlement on the adjacent structures built on this strata, please tell how you analyze the scenario.
Yes, this is correct. If you have a lot of water coming out, you can have a setting. So Dolenco drain is not meant to be leading groundwater. It's not meant to be leading a lot of water from the surroundings all the time. It's made to take the residual water that the structure, the lining doesn't take itself, right? So it's not meant like a just dewater the whole area. So that's the difference. And this is also why we say that, for example, when you make the second pile walls, we all know that the water comes between the piles, and if you have a bad concrete, a stone during the making the piles, you have water coming through some of these places. What you do is you basically take most of the water and address it so it doesn't flow in. You just address that. And what I mean by that is using the fast-setting mortar, the grouting or the injecting, or the line drain maybe at that point, and then let that, and then stop most of the water, and then put on Dolenco drain and put the lining on. And then you'll have water not coming through, and you'll have only so much water, so only the residual water coming in. And typically it's, I mean, I have the mesh is actually here. You can see, oh wait, you can see how elastic it is, but you can see the profile, and you can see the canals here. They can take much more water than we expect. So when you have the water coming in, it will be seeping in these. It will not be flowing like full strings. It will just be a little bit seeping in some of them somewhere. And that's how you do it. You just make sure that none of this water accumulates inside the structure, but only the residual water. Also, I would say it's a lot of it is what you call secondary water table. You know, the rainwater and this, and so it's secondary water that actually comes in when there's more pressure on. Maybe it's the river is rising sometimes. So that's what it is. It's not for groundwater, not for taking groundwater at all.
Okay. There is another question from Smaira Bansal. We have a case where a concrete line tunnel is tripping through cold joints. How Dolenco drains can help us with that? Will the lining needs to be chipped or installation of drains, the gutter and shortcut over it to be enough?
I don't think you need to chip it out first when you use the Dolenco drain. What you need to clean the surface, install the Dolenco drain, and cover with shotcrete. And now this is a very specific question from a real project, and I'm always careful about answering that, and I always want to ask more questions now. So I can suggest that if it's a specific need you have, that we set up a separate session meeting, an online meeting where we go through the details. Maybe you have the detailed drawings, you have pictures, a video from the place, and we can certainly discuss how to approach this the best way. We will be very happy to do that.
There is another question from Mr. Rishabh. He would like to understand how this Dolenco drain get attached to the soil or rock surface in case of very high water discharge, and what is the tensile strength of Dolenco drain material?
Well, the attachment of the Dolenco drain is with concrete nails, and we don't anchor the Dolenco drain to a soil surface, for example. In that case, we rely on it doesn't have any structural strength it doesn't add any structural strength to the lining. So that we rely on the shotcrete lining before the anchoring soil nails, and the shotcrete that comes after, maybe reinforced with a wire mesh. So this is what we're relying on for the structural strength. And what was the other one? The other part was about the capacity of the
Yeah,
water.
what is the tensile strength of Dolenco drain material?
Well, the tensile strength, it really doesn't matter about the nails, what that is, because what happens is that when you have, as you can see here, really you should look at the nailing as a temporary measure. You see the nailing points here. We have nailing points all over the module. And when you have nailed it onto the surface and you cover with shotcrete, you will have, as you see here, you have 70% of the surface free for adhesion between the concrete before and after. And that's what actually keeps the structure monolithic. So when you design a structure, you have to calculate with 70% adhesion of surface. So the focus should be on how is the adhesion. Do you need maybe you need a primer if you have a very smooth surface of the initial shotcrete. This is what you have to look at here. So, but that is always, we have never had any issues about this adhesion situation. So it's not about what do you call it? The pull test? What was the word?
Pull-out test.
Yeah, the pull test. Yeah, it's not about the adhesion of the mesh to the surface. It's only about the concrete, right? And that's what you have to count on.
Tensile.
Yeah, tensile strength. Thank you.
Yeah.
Yes, I'm from Denmark, so we are. English is not my native language, so.
So that's not an issue, sir. You are speaking very well.
Thank
There
you.
is another question from Sudeepa Das. What is the advantage of Dolenco drainage system instead of perforated drainage pipe and weep holes between rock bolts below the second pile where slope has been cut up to the bottom slab in grade 3 rock?
The advantage of I didn't get that. It's chopping
Uh,
up a little bit there.
Basically, he's trying to ask what is the advantage of Dolenco drainage system instead of perforated drainage pipes. We provide perforated drainage pipes in the drainage holes, and even we provide weep holes and below the in the tunnel and even in the slopes. And he's asking about
Right.
the same thing about that.
Yes. Well, first of all, if we take the slopes first, so the advantage is that the water doesn't go through the whole lining. It doesn't put pressure on the whole lining. It just comes in and is led to the base behind the lining. So you have a completely uniform surface of the concrete, and that gives the longevity for the lining, for the concrete lining, the longevity. Yeah, and we know that when you put the pipes on the entire surface, you have water being blocked from coming out through these pipes. It's a big problem, and so the water will be prevented from coming out. It will put pressure on the concrete. It cracks, and ice formation, spalling, and so on and so on. Growth on the surface because of the cracking. And this is a very big problem. And these things you can avoid or minimize by using Dolenco drain behind the lining. So you have a uniform lining with a drainage behind it, so the water doesn't go through the concrete. It doesn't soak. In the water into the concrete, so it will keep the concrete lining more dry and without any cracking. And this, of course, adds significantly to the lifetime of the structure. And the other was with second piles. And
Below
with
the
the
second page.
perforated pipes.
Yeah.
Yes. Normally what we see is being done is the perforated pipes are put at the base. Of course, you can use a perforated pipe vertically as well. You could do that. Again, that is a punctual approach, and you could do that in between all the piles. Also, this is also an option. That would be something to do instead of using Dolenco drain. It would be a different approach because you do it punctually. So you do it punctually everywhere, right? So it's just easier to use the Dolenco drain, and it will take the water also over the piles, no matter where the water will come in. So, but that's what you can argue in each project which is needed there. So that's how I would look at that.
Okay, that's fine. There is another question from Krishna Ray. Uh, Safety layer, you mean to say a slurry panel before concrete? Maybe
Yes.
he's asking. Yeah.
Yes.
Okay. There is another question from Rishabh Bharadwaj. How much reduction of water pressure should be considered for the design of concrete lining or oblique secondary lining?
Well, this is really not something I can answer. This is something that you will have to calculate yourselves in your models. I cannot do that.
Okay, okay, that's fine. That's fine. I have also one more question. If is there any impact of heat over the product if we are using behind the if there is no final lining, or is there any fire hazard or some incident happens? Is there any impact of heat over the product or not?
Yes. First of all, yes, there is. But first of all,
Okay.
when you use Dolenco drain, you always put a layer of shotcrete after mounting Dolenco drain. That's the first thing. Of course, this
Okay.
layer
Yeah.
works as a fireproofness, right? But the product itself, how does that act? Which is an important point. How does that act in case of fire? And the first thing that happens is that it melts. That's the
Yeah.
first thing that happens. If you have so much fire so long time that the concrete spalls off,
Yeah.
then
Obviously.
yes,
Yeah, there
then
will be scaling when if such kind of thing happens. But uh, if there is any testing, or is there any tests which we are conducting in for the fire or for the heat for the product?
yes, it is non-combustible. It will non-self-combustible. If you have fire, fire on it, it will burn. When you take the fire away, it will stop burning. So it's non-self-combustible.
Okay.
So it's not promoting fire itself. And the other thing is, which is important here, is there's no hazardous gas from the product being burned. And this is one of the reasons that we actually chose the material that we have. You see, the flexibility is one reason, because it has huge flexibility to the surface of the structure, and the other one is the safety of the product with the gases, and the third one is that it is 100% recyclable. So if you break down the structure, you can take it out and you can 100% reuse the material, granulate it, and make new products.
That's good. That's good. So since there are no further questions from the participants, we will bring this session to close. So on the behalf of our platform, I would like to thank you, Mr. Paulson, for sharing your valuable insights with us. And we truly appreciate your time and contribution, and we will look forward to future interactions. Thank you, Mr. Paulson, and thank you, Mr. Mark.